Okay, so as we look at number 1 on the homework, you ready? The first question that we need to address is this. Is there a difference between number 1 compared to 2 and 3? What is the difference?
You know the type of plane.
A, we know the type of plane. What else?
We don't know the
that's a
trying to find.
Okay, what is it we don't know about the resultant?
We don't know the miles per hour.
I don't know the magnitude of the speed of the resultant. Everyone agree?
Yeah.
Do I know the direction of the resultant?
Yes.
Yes, what is that?
West.
Due west.
Due west.
Okay? There's something else I don't know. What is it?
The plane's direction.
The plane settings direction. So I want to clarify a couple things as you check your picture. And we want to make sure that our picture is correct. This is where the resultant double arrow or different color can be helpful. Because, first of all, let's clarify our bearing. Listen to this question. In what quadrant is the wind? 4. Why? Jesse. Yeah. So the wind is going from due north 145 degrees down into here, which means how big is this direction angle? What kind of 55? Negative. Okay? There's the first part. Okay. So here's my wind going 45 miles per hour. Now, I do not know the direction of my plane. I know the speed of the setting on my plane. What's the speed? 540. But I don't know how I'm setting my plane. I do know that I better end up going how?
Due west.
Due west. So I'm going to have my resultant vector be a double line. Since I don't know the speed, that's obviously part of what I'm going to have to find, but I'm going to go ahead and clarify how many degrees is that? 180 degrees. So somewhere, and this is, some of you may in your gut know what this answer is, but do you know, can you tell in what quadrant the plane's setting will be? So it's, some people say 3, some people say 2, that's why it's a toss-up, right?
2.
It's going to feel like it should be either here or here. And in reality, it's going to end up in 2, but we don't know why yet, so hold tight.
Because then it would be going
Down. That's right. Yeah. Was everyone clear on that? Who guessed 3? So in reality, it's going to be in 2. But if you don't see that right now, that's fine. But do you see that it's not 1? Okay. So here's the next thing. What components are being combined to give me my resultant?
The wind and the plane.
The wind. So I'm going to need a wind vector, and I'm going to need a plane vector. And when I what them? I already wrote it. When I add them, I'm going to have my resultant vector. When I what them. Okay, now, we already said the direction of my resultant is how many degrees?
Sure is.
I heard it. 180. What goes right here? Cosine 180. Do I know the speed? No, so I'm going to, no. The 540 is the actual plane setting speed. And then we'll call this a sine of theta. Okay, now listen. Sine of 180, thank you. Sorry about that. What I want you to now do in your groups is write out the component vectors for the wind and the plane. Okay? Wind and the plane, go.
I know my wind would be
Because it tells you your resultant
45.
vector is due west.
south,
45
negative 55.
For X would be
And then
negative
45
540.
so you're 55.
Y would
Gotta
be
reduce
0.
all
I don't. And then plane.
The wind is 36.8.
The wind-
negative
Well,
45.
plane would be 5.
We know the speed.
So 540.
I was very unengaged until I remembered we had that number.
Okay, who's got the vectors for that? For the wind and the plane.
Is it also?
One group right here. Okay, wind. 2 groups. How about the back? Okay, do we know the angle for the plane?
No.
No, so if we don't, let's just call it theta. Does that help?
Yeah, isn't
I was
Two is the upper one.
It's one between.
Yeah, do we know the speed of the plane?
It's 540.
Okay, here we go. Who's got the wind vector? Feels pretty confident. Go Grant. Go Grant.
Alright, Steve just stole the words out of my
He
mouth.
totally did.
45 cosine negative 55,
Good.
and then 45 sine negative 55.
Okay.
You have to say -55.
Okay, if you've got the plane vector, Anna, go.
540 cosine theta and 540 sine theta.
Okay. Now, what is a little bit troubling about this scenario? How many unknowns?
At its top speed.
2, right? We have 2 unknowns.
boy.
Now, the beauty of these types of problems, however, is what is the cosine of 180? Okay. So if this is -1, this is negative a. This can be replaced by negative a. What is the sine of 180?
0.
Okay, so this whole thing is just 0. Okay, now listen to the next question, because we're going to use this in our later stuff. Which component, the horizontal, sum, or the vertical, which one am I going to want to start with to solve? The horizontal or the vertical? Okay, so if you said vertical, raise your hand. Okay, why is the vertical one easier to solve for, Nick? Because you only have one variable. So, because I only have one variable, I can write out an equation to solve. What's it going to read?
45 sine 55.
45 sine of negative 55 plus 540 sine of theta equals 0. Solve, please. Go. Discuss in your groups. Literally, what are you typing in your calculator? How are you finding your values? Find my theta.
Why is the plane vector negative 540?
Just solve.
No, so okay, so I think of it as a plane setting and a plane
45
result.
sine negative 55 and you.
Like what is what's in the cockpit? I can tell the plane the resultant is what is the plane actually doing when the wind is factored in.
-36.
And that resultant vector is what it's doing when the wind is factored in.
Yeah, but isn't the plane like without the wind going?
46.86.
That's like
Hold on, so we have
500 miles per hour.
54 sine theta.
No, without the wind, we don't know what angle it's going. We just know we want to go due west.
Was it Graham?
Negative 36.
Well, without the wind setting, it's 540 miles per hour.
Then inverse
So that would be the flip of
No.
this part too.
You're just
Wouldn't that be
you're not even doing anything wrong. It's not
like 36? I'd go to like.
You want your next one.
Oh.
But you have to set it to something else. Okay, if you got an answer, raise your hand.
I put in theory.
Okay, Heidi, what'd you get?
-43.3, which doesn't make sense, so I think I should add 180.
Okay, so I say this lovingly, no and no.
Yeah.
Did anyone get a different answer?
Wait, do you divide?
Does no answer count as a
Oh,
different
for
answer?
theta?
Yes, but what did you get first?
Negative 3.9.
You did not get -3.
Negative.
You should have gotten 3.91.
3.91.
Well, that's what I got. But it was negative
Okay.
36.
Yeah, you shouldn't have. So let's clarify a couple things. Okay. Okay, so I need you to zip and listen. Let's try that again. I need you to zip it. Shh. And I need to know mathematically what's happening here. 45 sine of 55, that actually has a value. What is its value? What did you say, Corey?
36.8. Negative 36.8.
Okay, so here's the deal. This negative aspect really does matter. My actual answer, if you heard what Corey just said, he's right, is negative 36.86 plus 540 sine of theta. Then what did you do, Corey?
I pretty much, since it's equal to 0, I put 540 sine of theta equal to 36.86.
Yeah, and then you divide by 540. Yep.
Oh, I did do
And
that.
then when you take the inverse sign, you get 3.91 degrees. Now this goes back to the earlier conversation we were having about making a decision based on the logic of the vectors. You get an answer that is 3.91, which is here. And yet, why can I not let that be the answer? Because my resultant has to be going due west. So, old school trig, you know that if I get an answer that has an angle in quadrant 1 where sine is positive, the calculator cannot give me the answer that also exists in quadrant 2. So my actual answer is in quadrant 2. Why? Because if it's up here, it can then pull the plane due west. But these sides have to be the same, so therefore, how do I find the actual, Grant, you found this, how do I find the actual angle of the plane in terms of its setting?
Well, I found a different way, but when you just take 180 minus 3.9.
Yes. 180 minus 3.91 is 176.09 degrees. That is the direction that when I get in the cockpit, I set my plane to go so that the combination of the plane and the wind cause it to go due west. Now we're not done.
That's speed.
So now what? What do we still have to find? A. We've already used the vertical component to find theta, so now I'm going to use the horizontal component to find my A value. So with that, in your group, set up a equation and solve.
Okay, so we have to do
So A is 512.
So we have theta.
Pretty much
We know what
just
theta
put
is.
in
Add the two and then
25 cosine
I
855
will tell you, I don't
plus
mind
540 cosine 176.0.
what I
That's
would
how we do it.
do it.
Why do I
Wait, we have to find the base.
wait. Theta, do we plug in
Well, I just
1.09 or plug in 1.09?
She said
Why would you plug in that number?
176.
You got that number from plugging in the other number.
Okay, when you got an answer, raise your hands. Oh, nice. Look at all these hands. Good. Okay. Steven, go.
Grant has our answer.
It's 512.93.
Yes, did we get that?
Let's go.
Yeah.
Really quickly, what is the equation? Yeah, Heidi.
45 cosine negative 55 plus 540 cosine 176.09 equals negative A.
Yeah, plus 540 cosine of the angle we just found equals negative A. And when I solve for A, I get 512.93.
Yay.
Label it, please, to get miles per hour. Ava.
I still don't understand why this
Subtract what?
Because you're getting the other angle. You're getting the other angle.
No, I was like having no idea where any of
Plus
these
you
numbers
get
are coming
theta
from.
the
Okay.
Minus 3.9.
I should not be a math teacher.
Okay, so hit pause for a minute. Let me go back to Ava's question. Okay, so 3.91, you're talking about back up here.
Yeah, like I know you can't say that.
Okay, so did you put that in your calculator? The inverse sine of 36.86 over 540?
And then you, yeah, no, I know that that's what it is.
Okay,
Why do we-
because the calculator can only give me an answer in quadrant 1 and 4. So it knows that the sign is positive, so it gives me the answer in quadrant 1. But that doesn't make sense in the context of my vectors. So I have to translate it to quadrant 2, but it has to have the same reference angle, so it's 176.09. Is that better now? Okay. Then I use that horizontal component.
And you just put
Yes. Then you just plug it in. Okay. So the only thing that we're going to now add to this is a new way of looking at magnitude and a new type of word problem. Now, you got notes from Wednesday. Will you get out those notes, please?
I mean, I guess.
If you
Thank you. Okay, so when you turn to these notes, you're going to see Newton's first law of motion.
Why?
Yes.
Thank you, Corey.
So much fun. Liam, can I have like the
No,
top
part
line
one.
so I can do the notes?
If I wanted this, I would still be in first period.
Okay, on Newton's first law of motion.
I can't write right now.
Read that to yourself. Take 10 seconds. Read it. Look up here.
No, I said zero.
Ben.
Oh, Newton's fourth law. That's pretty good. You hear that, Miss May? Thank you.
There is a commercial. Have you seen the commercial that says, a body in motion tends to stay in motion.
Yes.
A body at rest tends to stay at
And
rest.
he's like,
And then
seriously,
the
the
property
property
of
of matter.
I know, and I'm pretty sure it's for like some sort of like
It's for like energy as a
medicine for old people. Yeah. So the key to that concept is considered Newton's first law of motion. I'm going to take a sophisticated physics idea and I'm going to pull it down into the world of pre-calc. We're not going to overly complicate it, other than to say that whether it's an object at rest or an object in motion, no matter what, the object at rest will stay at rest, or the object in motion will stay in motion when the forces acting on that object have a sum of 0. Meaning, let's say I have, in a second we're going to look at a sine, and the sine is going to be affected by gravity, except we're going to have 2 wires that pull it up. And the sum of each of these vectors acting on the sine will add up to 0. In your homework, you're going to do a body in motion. So you're going to have a barge pulled by one horse on one side and one horse by another on the other side. And as long as one horse moves and another horse moves, the barge still moves. Same concept is that motion, motion, motion stays in motion when the sum of the forces acting on the item is 0. Now, to have this better conversation, we are going to add on one quick definition. We've been saying magnitude is what? Velocity, distance. We're going to add on one other concept, and that magnitude is going to be interchangeable with force. Now, in a physics world, that gets explained in a lot of detail. In pre-calc, you're going to mostly accept that as true. And we're going to look at this first example. You ready? Okay, look at the sine example. And can I get a volunteer to read that out loud? Go, Steven.
The source sign is being held up by 2 wires as shown below. Newton's laws of motion tell us that since the sign is static, the forces acting upon it must be in balance. That is, they add to 0. There are 3 forces acting on the sign. Each wire is pulling on the sign, and gravity is pulling the sign down. If each wire makes a 140-degree angle at the top of the sign, that is pulling on it with a force of 100 pounds, find the weight of the sign. This is equal to the force of gravity pulling it down.
Okay, so you essentially have, you ready? A wire, we'll call it wire 1, a second wire, and gravity, all as acting forces. And what did we say now for like the 3rd time? The sum of those forces is 0. It basically balances each other. The forces balance each other out so that the item stays in motion or stays at rest. Okay, the concept for each of these is similar to what we just did. Each will have its own component vector. The difference is, what did we say? Magnitude is replaceable by force. Okay, so we're going to do one together, and then you're going to try one in your groups. So one thing to comment on as we begin to have these vectors with Newton's first law of motion is, anytime I have a force acting on an object, I'm going to create my own little axes. So, for instance, this wire right here is going to be one axis. This wire here is a second axis. And gravity, its own axis. That should be in the middle of the picture. So when I go to write the horizontal and vertical components, magnitude is replaced by force. A wire either of the wires has a force of 100 pounds. So if you think you've got an idea of what that first wire component looks like, we go for it, Grant.
So like 100 cosine, 140,
Yep, and
100 sine.
okay, easy enough. Okay, do not go get ahead of me because I don't want you to get thrown off. Just find the other two components. Wire 2 and gravity, go.
I could also just be stupid.
Okay, if you got it, raise your hand.
W2 not be the same thing, though?
What's that?
Wouldn't W2 be the same thing?
No,
Because of the angle.
The angle.
because of the angle. What? Remember, we just said that's why those little drawings matter. At any given point that some force is acting on the object, I have to have my own what?
Axis.
Axis. So, yeah, say it, Emma.
So 40.
Yes. So it's going to be 100 cosine of 40, then 100 sine of 40.
Which one is wire 1?
I had wire 1 on the left. It doesn't matter though. Yeah.
Since when is the magnitude I thought you went to
Well, yeah, but remember, once we started doing word problems, we talked about how magnitude and velocity are interchangeable.
Oh, yeah.
Okay. Okay, if you got the gravity vector, raise your hand. Gravity vector. Gravity vector. Gravity vector. Who's got it?
Starts at 200. I don't know what you do.
Oh, wait, what, Ben?
9.8 something.
Oh, you're giving me the actual gravity value? Well, it's different though, because what don't we know about it? The weight. So I'm going to call the weight A, but what do I know? I know the angle. What is it? Good, 270. A cosine of 270, A sine of 270. Okay, A. So these add up to be,
Wait, but we do know the weight.
we don't know the weight of the sine.
Well,
Because it's
the
100
sine of
pounds.
270 is 1.
No,
and
the
cosine
wire
of 270 is
pulling.
0.
What?
So the
That's
first
the
part is
force.
actually 0, and the second part is actually just A.
The wire force is 100.
Well, that means the sine is 100.
Whoa.
It doesn't.
Cosine of 270 is 0, so you can get rid of that.
That's also
Hang on. Can I just keep going and then we see? Okay, so I'm gonna go back to this.
That third one is for the sine, right? Like the
The
sine
third one is
itself.
for the gravity of the sine. Okay, so I heard a bunch of people say, what is the cosine of 270?
0.
Yeah, the cosine of 270 is 0. Now listen, don't miss the logic behind this. 140 and 140 have the same reference angle, agreed?
Correct.
Okay, but if I have 40 here and 140 here, their cosines are opposites. So these two better be opposites because they are supposed to add up to 0. What is the sine of 270?
Negative 1.
So this is really negative A. I'm making a video of this. Can you imagine what it's like to listen to this later?
Making me a
I probably should have told you at one point. But I feel like if it's fourth period people listening, it's fine. But first period who doesn't understand fourth period, they're going to be like, those guys are so much more active.
Well, it's also not the quick.
Also, like,
Shut up, all of us, man.
Okay. This is more talking than first period has experienced like all year long. Yeah. Okay. So how am I going to find A? I need an equation to solve. Jesse, go.
100 sine of 40 plus 100 sine of 40 plus a sine of 270. Wait.
Well,
plus negative a.
yes.
A equals 0.
Okay, solve. Raise your hand when you got an answer. You're literally just going to put those values in. You're going to solve for A. I need a decimal for 100 sine of 140. I need a decimal for 100 sine of 40
plus negative A?
because that's what my vertical component's doing. This vertical plus that vertical plus negative A.
Yeah, I get it.
Why is it equal to 0?
Because all of my vertical components add up to 0.
I wonder why.
The sum of these forces acting on the sine give me a sum of 0. That's just coming from Newton's first law of motion. Okay. Okay, got an answer?
This is getting awfully complex.
Yeah.
Is it negative
It only-
128.5?
It doesn't get. It gets a little harder than this.
128.
Yeah, 128 point what?
540. 540.
I got 5. Yeah, I got the same thing. Are we okay?
You just find a number.
Let's figure out what
120.
the
the number and then A
Find
plus that.
that.
Wait, what?
Wait, why
It's
is
just a regular thing.
Are you okay?
Oh wait.
Abe, are you okay?
You just
Okay,
subtract
so
it and get from all the sides.
let's talk this
And then
through.
negative A equals that number.
Yeah. Are you plugging it in, Ava?
It's like a regular equation that I learned in like
Okay.
seventh
Hey,
grade.
I need you to be quiet, please. Shh. Okay, so if you're comfortable just straight up explaining what gets typed in, will you raise your hand? Like you're willing to do it? Okay, Heidi, go.
I mean, you type in 100 and then hit the trigger button and then hit sign and then 140. Then
So let me pause for a minute. You're literally just getting that decimal representation with that. Do you get that?
Yeah, I have it all put in.
Are you in degree mode? Maybe
You
not.
should be in degree mode, right?
Yeah, you should be.
Oh, okay.
Okay, we're okay? I'm gonna keep going then. Okay, all right, so all I want you to do is look at your homework now, which is Vector Applications Part 2. I completely butchered the numbering on this, so I'm gonna refer to them
Let's go.
by their words. Okay?
Let's just do 1 and 2.
Let's not.
do it.
So there's 2 twos.
encounters a win.
Okay, here we go. So, do you see the plane problem on the warm-up?
Yeah.
Okay, we're gonna do that on Monday. Turn the page. Okay, there's a piano problem. We're gonna do that on Monday. Your homework is to do the sign problem. You see it?
Yeah, is it the first one on the next
Yep. The sign problem number 2. Go to the next page.
Which one's the sign
number
number?
2, right?
3.
Oh wait,
So sign number 2. Nice.
That's
Can
just-
someone point to
that's
the
just
Charlie,
number
please?
2.
Do we
It's
do
the first one.
It's the one
do
that says
Miss
all
Heinrich
sign.
in a motorboat?
No. You're doing the ones I'm telling you, right?
we already did
This
one.
is the problem with
I
smell
like
Right. The idea is to generally replicate the same process before we make it harder.
It's gonna get harder. I don't
Turn
know
the
if you
page.
can make it.
Watch. Number 4, there's a pirate problem. Do you see that?
Yeah.
Okay, you're gonna do that. That has a similarity to, or a similar aspect to the sign problem, but they're with different angles.
How did you number
And
this?
then, if you go above that, there is a motion problem. Number 3 is a
What's number
motion.
3?
It actually is also in terms of an ocean.
Ooh, yeah.
But all you're gonna do is set that up.
Set it up.
So you are literally just doing 2.5 problems. You're gonna do the sign problem, do the pirate problem, then go back and attempt to set up the ocean liner problem, but don't stress if you don't. Like all you're gonna do is try to set it up.
It's the
What
one
is
with
that?
the
Okay, I'm going to stop recording so no one else has to hear me answer the
Smell
same
like-
question again.
I smell like